Hi folks, we're going to do a problem involving bulk modulus. Here's my situation. A farmer marketing grape juice fills a glass bottle to the brim and caps it tightly. The juice expands more than the glass when it warms up, in such a way that the volume increases by 0.2%. That's a change in volume compared to original volume of 2 times 10 to the negative 3 relative to the space available. What's the force exerted by the juice per square centimeter if the bulk modulus is 1.8 times 10 to the 9th newtons per square meter, and assuming the bottle does not break. So let's do part A first. Here is the equation for bulk modulus. The change in volume of an object is going to be 1 times the force times the original volume divided by the bulk modulus and the surface area under discussion. We want to solve for force, so force is going to be equal to the change in volume compared to original volume times the bulk modulus times the area. So if I put my numbers in, here's what I've got. I have been told that the change in volume compared to original volume is 2 times 10 to the negative 3, that is a ratio, ratios are unitless, times the bulk modulus. In this situation, it's going to be 1.8 times 10 to the 9th newtons per square meter. And the question says this volume changes up per square centimeter. So I'm going to have to do a little math before I can just put the number of area right in here, because this is a force per square centimeter. 1 cubic centimeter, I said cubic, square, I want square, sorry. I want to get rid of centimeters, go to meters, 100 centimeters in a meter, get rid of the other centimeter, going to meters. There are 2 of these, so this takes care of one, this takes care of the other, and so the area I'm actually talking about here is 1 times 10 to the negative 4th meters squared. So that's the area I'm going to put up here. Remember, you always have to keep your units consistent through a problem, otherwise you end up with guacamole. All right, now that I've got this, I throw it all in my calculator and I end up with 360 newtons per 1 cubic centimeter. I'm going to write it this way so the units don't get confusing, and that's going to be the force that is exerted on this bottle. Now the second half of the problem says this. They want us to make a prediction. Do we think the bottle's going to break? And I don't know if the bottle's going to break, so how do we figure that out? We're going to calculate the pressure by converting it to atmospheres. And so this is how this works. The force on the bottle was 360 newtons per cubic centimeter. Well, I can't get that. Actually, newtons per cubic centimeter, we're now talking about pressure, force per unit area. But in order to convert to atmospheres, I have got to convert this into pascals, and a pascal is a unit of pressure which is equal to a newton per meter squared. So one more time, I've got to get rid of centimeters, go to meters, 100 centimeters in a meter. That takes care of one. I'm going to have to get to the other one, which is going to get rid of the other 100 centimeters in 1 meter. So this is going to end up 3.6 times 10 to the 6th pascals. Well, that's charming, but it says atmospheres. Atmosphere is a unit of pressure where 1 atmosphere is equal to 14.7 pounds per square inch, which is kind of typical sea level atmospheric pressure, and it also happens to be equal to 1.013 times 10 to the 5th pascals. So I'm going to have to convert pascals into atmospheres. 3.6 times 10 to the 6th pascals. I want to get atmospheres. 1 atmosphere is equivalent to that many pascals, 1.013 times 10 to the 5th pascals, and when I do the math, I end up with 35.5 atmospheres. That is over 35 times more than the weight of the air pushing down on something. To give you an idea, an open water scuba diver only goes down about no more than about 4 atmospheres. This is huge, and yeah, the bottle's gonna break. Alrighty, you have a grand and lovely day, and we'll see you later.